Hello everyone, and welcome to another fun STEM demonstration. Today I'm showing you more science magic. Before me you see 3 test tubes. Each test tube has the same amount of clear liquid inside of it. And here I have a graduated cylinder full of purple liquid. What do you think is going to happen if I combine this purple liquid with the clear liquid in my test tubes? All right, first test tube, ready? What will happen to this liquid when I pour my purple liquid in? What color will we get? All right, pour it in, give it a shake, and we have a test tube full of purple liquid, just like the purple here. Maybe a little bit lighter because we mixed it with clear. Fantastic. Well, now that we've done that, let's test our second test tube. So again, we have clear liquid, purple liquid, and when we combine them, what's this? Give it a shake. Well, that's a different color, isn't it? And how about our third test tube? Clear liquid, purple liquid, and when we combine them, give it a shake. And now we have blue. Magic, right? Well, if you've been watching my videos for a while, then you know, no, it's not magic, it's just science. So, how did I make this happen? My magical color changing liquid? Well, I'll give you a hint. In one of these test tubes was water, but in the other 2 were just clear solutions that looked like water but were something different. So my first test tube was just plain water out of our faucet. My second test tube, though, had white vinegar in it, and my third test tube had baking soda dissolved in water. Because I had different substances in each test tubes, they turned different colors. But why? My purple liquid here is actually red cabbage juice, which I made at my apartment. So why does red cabbage juice turn different colors depending on what you mix it in? Well, it's because red cabbage contains an enzyme called anthocyanin. And anthocyanin is a natural pH indicator. A pH indicator is a number that's assigned to every liquid that tells us how much of an acid or how much of a base that liquid is. So a neutral liquid, like water, would be given the number 7 on our pH scale. And then super acidic numbers would be smaller and basic numbers would get bigger. So the farther away you are from the middle, the stronger the chemical is, and the closer to the middle, the more neutral the chemical is. And when anthocyanin comes in contact with an acid, it turns red or pink. And when it comes in contact with a base, it turns green or blue. And the strength of the color is determined by the strength of the acid or the base. So it will be a stronger change depending on how strong the substance you combine it with is. So we combined with vinegar and baking soda. Vinegar is an acid, baking soda is a base. Now I have some other substances here as well. This is lemon juice. This is iodine, and this is isopropyl alcohol. So we're going to try this experiment again with these liquids, and I want you to try and guess what color they're going to turn. Will it stay purple like our water? Will it turn pink or red because it's an acid? Or will it turn blue or green because it's a base? Let's test the lemon juice first. What's your guess? Make a hypothesis. When I pour our anthocyanin-laden solution of red cabbage juice into our vial of lemon juice, what color will the lemon juice turn? Ready? Were you right? Lemon juice, like vinegar, is an acid. And so our liquid turned pink. Let's make this into a sliding scale. All right, so lemon juice turned pink. And I think that this is a pinker color, a stronger color than this one. So I'm gonna put it on this side. Next we have our isopropyl alcohol. This is just rubbing alcohol that you can buy from the drugstore. What do you think? When we combine it with our red cabbage juice, what color will this liquid turn? Will it stay purple, turn pink, or turn green? What's your guess? Are you ready? All right, so our isopropyl alcohol is mostly staying purple, but it's not as purple as our water. So it might be just a little bit acidic because it's coming slightly towards pink. All right, our last vial that we're testing today. This is decolorized iodine. Iodine is normally a really dark yellow-brown, but this one has had the color taken out of it, so it's closer to being a clear liquid and will show us our result of our experiment that much better. So, what is your guess? When I combine my red cabbage juice with my decolorized iodine, do you think it's going to stay purple, turn pink, or turn green? What's your guess? And here we have our iodine, and that has turned green. And again, it's a stronger green color than our baking soda mixture, right? So now we have our whole pH rainbow here. So we start with neutral. This is water, it's neutral, it's gonna be a 7 on the pH scale. And then we have our 2 bases to this side, and we have our 3 acids to this side. As the color gets stronger, the acid gets stronger and the number gets lower towards 1. And as we get stronger with our bases on this side, the number gets higher towards 14. So everything in the world is on the pH scale from 0 to 14, depending on how strong it is and whether or not it's an acid or a base. So why is this important? Well, it may not be important for you to know right now beyond just it's kind of a cool trick to show your friends. But scientists use this knowledge of the pH scale and how strong something is acidically or basically to do all sorts of important experiments and to learn all sorts of important things about the world around us and how it works. We want to be able to know if the water falling from our sky is the neutral that it's supposed to be, or if chemicals have gotten into our water cycle and turned it acidic. Because the stronger a liquid is towards each extreme, the more caustic it gets. It can start to eat away or damage all sorts of material that it falls on, including your skin. So you really want to know if the rain falling from the sky is the neutral pH it's supposed to be, or if we're creeping down towards something called acid rain, which is not good news for anybody. But at the same time, sometimes you need a substance that's going to eat through something quickly. And so you're going to be looking for something that's more caustic. So the pH scale is a really important part of nature to be familiar with. So if you want to do this experiment at home, here's what you're going to need to do. Get 1 head of red cabbage, chop up about half of it into small pieces, boil about 2 cups of water, and then pour the boiling water over your cabbage and let it steep for about 10 minutes. Then you drain off the cabbage. Maybe you can use it in a soup or some egg rolls so it doesn't go to waste. And you save this liquid. And then you have your anthocyanin-laden pH indicator. And you can test it with things that you find around your house. But this is your science safety reminder. You want to make sure that you're doing this activity with an adult who's there to supervise. Because when you're making your red cabbage juice, you're going to be boiling water, so you need to be very careful with adult supervision for that. And you also want to get permission because you are going to make your whole house smell like cabbage for a few hours. And then when you're finding liquids to test, please make sure you stick to items that are in your kitchen and maybe your medicine cabinet. Remember, the stronger our acids and bases are, the more caustic and potentially damaging they become. Everything that I used is still fairly weak on the pH scale. So if I get it on my hands, it's not going to hurt me. And I want to make sure that if you're doing this experiment at home, nothing is hurting you either. So please make sure that parents are close by to help with this experiment and test out things that you find in your kitchen, like lemon juice or vinegar, maybe orange juice or grape juice, maybe milk. What sorts of drinks do you have in your refrigerator, and how do you think they would react with the anthocyanin? Remember that this is baking soda dissolved into water, so what other powders you might find in your kitchen, like baking soda or baking powder or salt or cornstarch, how might those change color when we dissolve them in water and then combine them with our red cabbage juice? There is so much experimenting that you can do safely with this activity, and we look forward at the library to hearing how things go. Maybe take a few pictures and come in and show them to us. And we're going to be keeping our pH rainbow on display for the next few days in the children's place. So come on in and check it out in person.
Hi friends, it's Cassie. I wanted to cut in really quick to show you something really cool. So we left our pH vials out so that we could show them to you when the video went up if you came into the library. And I'm coming back the next morning and look at this. Do you see this one here? This was our rubbing alcohol, and remember in the video it was pink between this color and this color, and now it's gone completely clear. And if you look over here, this was our iodine, and it was that really bright green yesterday, remember? And now it has faded to this yellow-green color. I don't know exactly why this is happening. I have to do some more scientific research, but my hypothesis is that something in our isopropyl alcohol and our iodine breaks down pigments. That's what's happening. It's bleaching our red cabbage juice. Science is pretty cool, guys.
And until next time, friends, goodbye.